Today, we're going to be talking about rate of change. Rate of change is the ratio between the change in y values to the change in x values. Ratio is a division. So we are dividing the change in the y values over the change in the x values. Another way to write this is to use delta y, because that means the change in y over delta x, which means the change in x. And we use the variable m to represent rate of change. Now let's look at a verbal representation. This would be a word problem. Let's take this example. Verizona Mobile charges $60 activation fee and a $40 a month for the unlimited access to the phone plan. When we're looking at a word problem or a verbal representation, we're going to look for some key words that are going to help us to identify what the rate of change is. Some key words for a verbal representation would be per, each, every, monthly or a month, and so on. Any word that would represent that it is a reoccurring cost or a reoccurring number over and over again, then it is going to be your rate of change. So in this word problem, where we talk about the $40 a month, that means every month you're going to pay an additional $40. We could set up a table to represent this. X is going to represent the number of months, and Y is going to represent the total cost. So X is your months, and Y is your total cost. At 0 months, that's when you start the plan. And we know at 0 months, you're going to pay that additional $60 activation fee. After the first month, you're going to add $40 to that amount, and we end up at 100. Notice how we added 1 month to the plan. Next, we're going to add another month to the plan so that we are at 2 months, and every month we are adding that $40 for the access. This could continue for however long you have the plan. So now we're going to look at our rate of change, which we represent by delta y over delta x. Delta y means the change in y. The change in y is whatever we are adding or subtracting from that y value. So it's 40 in this case. We're adding $40 each month. And the change in y is how many months are we counting at a time? We're counting 1 month at a time. So our x value is 1. So that means our rate of change, or our m value, is 40. Again, $40 a month tells you that our rate of change is going to be 40. Next, we're going to look at a numerical representation. A numerical representation are coordinate points. Coordinate points are written in the form x, comma, y. These coordinate points could be transferred to a table so it's easier for us to find the rate of change. When we are making a table, we have one column, that's the x column, and the second column is the y column. We're going to take those x and y values from the coordinate and simply write them in a table format. So -3, -9, -1, -3, 0, 0. From there, we can find the rate of change by determining how did I get from -9 to -3. That's the change in y. Well, the change in y from -3 to -9 to -3 is 6. And what is the corresponding change in x? How did you get from -3 to -1? That would be a change of 2. We're subtracting. How did you get from -3 to -1? By adding 2. How did you get from -9 to -3? By adding 6. So the change in y over the change in x is going to be 6 over 2. Now let's check the next point. How did you get from negative 3 to 0? By adding 3. And how did we get from 1 to 0? By adding 1. Notice that this is a different rate of change, but when you write it as a ratio, it is the simplified version of 6 over 2. So 6 over 2 is equal or equivalent to 3 over 1, meaning it is the same rate of change. Our rate of change for these points is 3. When we look at an equation, we're going to look at the rate of change as a coefficient. In 7th grade, you learned the formula y equals kx, where k was your change value. In this case, our k value is going to be located in front of our x. So our rate of change, or our m value, is the coefficient of our x, negative 3. So this is our rate of change. We could make a table, x, y. We could plug in numbers such as negative 1, 0, and 1 into this formula, where we have negative 3 times negative 1, and we get 3. Negative 3 times 0 is negative 3. And negative 3 times 1 is negative 3. There is our rates of change. In the second equation, this is what we're learning in this unit, y equals mx plus b. This is slightly different from the first equation because it has a constant that you are adding at the end. So our m value is still located next to the x. So the number next to the x is your rate of change. So for this equation, our rate of change is 1/2. Our last two examples is a picture representation and a graph representation. In this picture, we're talking about stage 1 and stage 3. I can create a table where X represents the stage that you're in, and the Y represents the shape, how many shapes there are. So in stage 1, there were 4 shapes, and in stage 3, there's 1 shape. Now that I have these numbers, I can find my rate of change by finding the change in Y over the change in X. How did I get from 4 to 1? By subtracting 3. How did I get from 1 to 3? By adding 2. So my change in Y is negative 3, and my change in X is 2. Therefore, my rate of change is negative 3 over 2. And we leave it as a fraction. Finally, we're going to talk about graphs. When we're finding rates of change of graphs, you can find points on the graph that fall exactly on the crosshairs or on the X and Y intersections. So I'm looking for points where they cross exactly on that X and Y. And we have the change in Y over the change in X. You could plot these points in a table, as we've done on all the other examples, or we can follow what's called rise over run. Rise represents the change in Y, and run represents the change in X. When I rise, I'm going up how many, and when I run, how many am I going over? Notice that this looks very similar to what we did with Pythagorean theorem. We're making these right triangles to determine how far up and how far over we're going to change from one point to the next. So in this example, we're changing a rise of 1 and a run of 3. Let's try another point. I could change from this point here. I'm going to go up. And now I want to run to this further point. That's okay, we can still do that. This is a change in 3 over a change in 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to write the change in Y over the change in X, which is 3 over 9. Notice that that also simplifies to 1/3. So it is the same rate of change. It is proportional even though one triangle is smaller than the other. This is rate of change, the change in y over the change in x.